A construction project requires the installation of concrete I-beams. The dimensions of an I-beam are shown below. Note that 9 with 2 apostrophes is 9 inches. If the project requires 20 I-beams, approximately how many cubic feet of concrete is needed to pour these I-beams? Round your final answer to the nearest cubic foot. Okay. So right here, what we're focused on here is volume. So we're looking at volume, and we knew that because of the cubic foot. Next, the volume here, it looks like we're just going to be doing for a rectangular prism. If we look at that, volume for a rectangular prism is just length, width, height. Next, we need 20 of these, so we're going to be doing 20 I-beams. Okay. So from here, we're going to do the following. We need a first. I'm going to draw this so we can kind of figure out what we're doing. I'm just going to draw the two-dimensional shape. And it's not perfect because this shouldn't even be connected. It should be connected. But remember, when you're doing the test, you don't want to be wasting your time. So this is going to be 1 inch. This right here is 0.7 inches. To the top to the bottom of this beam, it is 9 inches. And the width is about 8 inches. It's fine. Okay. So I'm looking at this, and one of the main things we have right here is they want your final answer in cubic foot. They want your answer as a foot. And one easy mistake we can get with this is if we don't do our conversions right. So luckily on the EOC, they have it where 1 foot equals 12 inches. They give you this information. So the first thing I'm going to do is I'm going to do conversions right here and see what we got. For the height of this right here, this would be equal to 1 inch is equal to 1/12 of a foot, 1 apostrophe. Here, 0.7 inches. We could convert that, but I don't want to worry about doing 7/10 of 12ths. Let's not worry about that. Just keep it as a decimal because this is a calculator section. We can use a calculator. So we have 0.7 over 12 feet. This is equal to 8/12 of a foot. Here, this would equal 9/12 of a foot. Alright. So what's important here? Well, we got to break these apart. So we know that the distance, if we were to draw this out, is going to be 40 feet. And that's for all of them. And luckily we convert everything to feet already. So just if you were to draw these steel beams all the way out, we know that it would be 40 feet, okay? So let's not waste our time with that. Let's try to break this into formulas. So let's focus on the top beams first. We'll call that 1, we'll call that 2 and 3. These are the same. 1 and 2 are the same. So volume, we have the height, which is 1/12 of a foot. We have the length of it, which is going to be 8/12 of a foot. And this is for 1 and 2. And last we have the width, we have the width, we found the height, now we have the length, which is 40 feet. So what we're going to do for the volume here is we're going to find it and multiply it by 2. 1 times 8 times 40, 1 times 8 times 40 gets you 320. And then we got to make sure we multiply the denominators. 12, 12, 1. 12 times 12 times 1, you get 144. 320 divided by 144 gets you 2.2. So the volume here would be 2.2 dot dot dot. I'm just going to leave it like this. Multiply this by 2. So we get about 4.4. This is for the top and the bottom, 1 and 2. But we need the middle. So here the middle is going to have 0.7. So let's start the middle. This is for number 3, the middle beam. Volume here will be equal to the following. Here, let's start with the width of it, which would be 0.07 over 12. 0.7 over 12 feet. If the full height of this is 9, and we know this is 1 inch, therefore the height of this would be 9 minus 1 and 1, which would be 8, 7. So that would be 7. The height of this would be equal to 7 over 12 feet times 7 over 12 feet. And we know that the length, if it extended, would be 40 feet. So here the volume would be, let's multiply the numerators first and then do the denominators. 0.7 times 7 times 40 gets you 196. 12 times 12 times 1, 141, or 44. So we do 196 divided by 144. You get 1.36. We'll just leave it at 1.36. So that was 4 repeating. We'll just leave it like that so we have both hundreds. So what we're going to do to find the volume is we're going to add these two plus this to figure out the volume. So the volume of a singular I-beam would be 1.36 cubic feet plus 4.4 cubic feet. You get about 5.8 cubic feet. That's just for one singular I-beam. If we can recall at the beginning, they want 20 I-beams. So all you do for this part, just multiply the volume by 20. So 20 I-beams for the volume is equal to 20 times 5.8 feet cubed. So in your calculator you would just do 5.8 times 20 and you get the volume is equal to about 116 feet cubed. So lots of messy work. If you weren't listening and following along, it would be kind of hard, but that's it.